So, this is question 3 for Edexcel's FP1 June 2015 paper. Now, this is kind of crucial, just to mention that it is not a proof by mathematical induction video, okay? Because all it's asking us to show that the sum of r plus 1 times r plus 4 between the values of n and r equals 1 is equal to n over 3 times n plus 4 times n plus 5, okay? Now, the first thing we need to do, okay, is, well, we need to show that one thing is equal to another. So basically, we need to do this sum, and we need to expand this r plus 4 times r plus 1. I've kind of already done it there. Well, I have. Okay, just dim down expectations there. So we've got r squared plus 5r plus 4, okay? And there's no formula that we have, okay, that enables us to just go, right, this is what the sum of r squared plus 5r plus 4 is equal to. Well, we know it's eventually going to be equal to n over 3 times n plus 4 times n plus 5, but we need to show that. We can't just say, therefore, we just do a little bit of the work and say, we've proved it's equal. We haven't. We actually need to sub a few things in here. And it's given us a bit of an example at the start. It said, using the formula for the sum of r and the sum of r squared. Now, I've labelled the what they are equal to, so the sum of r is equal to n over 2 times n plus 1, and the sum of r squared is n over 6 times n plus 1 times 2n plus 1, okay? So, what we need to do here is essentially split it up, because what we're saying here is the sum of r squared plus 5r plus 4, well, that's the same as saying the sum of r squared plus the sum of 5r plus the sum of 4, okay? We all look between values of n and r equals 1, because all we're doing there is just adding them all up and writing them as a single sum, when you can split them up and work them out individually. Okay, so the first one is going to say the same, so with the limits of r and r equals 1 and n, okay, so sum of r squared plus, now what you would want to write there, okay, is the sum of 5r. But what that's saying there, obviously between the values of n and r equals 1, is the sum of 5 times r. Now that's the same as saying 5 times the sum of r. Okay, so we're just taking 5 out as a common factor there, so you could do that, and it would definitely help. Okay, so what you'll be doing next is therefore you'll be adding on the sum of 4. Now, this, you do need to just really remember this, there's no real kind of thing to it, but what we're adding there is the sum of 4 from r equals 1 to n. So in other words, we're adding 4n times, so it's plus 4n, okay? So what we need to do now is just sub in our values for the sum of r squared and the sum of r, etc, etc. So the sum of r squared, we've got it over here, okay, it's n over 6 times n plus 1 times 2n plus 1, okay? And we're adding that to 5 times the sum of r. Well, the sum of r is n over 2 times n plus 1, so you do 5 times that, so you get 5n over 2 times n plus 1. Okay? And then, as I said, the sum of 4 between r equals 1 and n is simply 4n. Okay? So what it is now is we're just a case of simplifying down and seeing if we could get to this n over 3 times n plus 4 times n plus 5. Now, one of the things I want to make quite clear here, if you get absolutely stuck, and you know, I'm just saying this just because I might, okay, so put your maximum faith in me, of course, but because we're asking it to be equal to something else, you can almost work backwards. So you can go as far forward as you can with the left hand side of this. Now, I said I'm not relating it to proof by mathematical induction because it isn't that, but I'm just saying left hand side, right hand side, so that's what my experience. I mean, I'll shut up and wave my arms around and whack my head on whatever it is, this thing in front of me. Okay, but what I'm trying to say is you can always work backwards so you can meet in the middle. So you can go as far as you can with this idea, simplifying it down, and then you can work backwards from what it's asking you to show that it's equal to, so you can kind of just as though you could just work straight through it. And it'd become more obvious if, you know. So basically, if you were to work backwards, you would expand the n plus 4 times n plus 5. You would times it by n over 3 and see what this would have to eventually end up equaling. Okay? But as I said, that would be kind of a last resort. And you wouldn't make it look too good if but anyway, it doesn't matter, they can't do anything about that. Okay, so the first thing you need to do is obviously expand n plus 1 times 2n plus 1. Okay, so I just do it at the top here. So we're times it, we've just expanded that quadratic there. So n plus 1 times 2n plus 1. Okay, so it's just a case of 2n times, it's just a case of simply expanding this quadratic. So we get 2n squared, okay, plus 2n times 1 plus n times 1. So it's just simply plus 3n, okay, then it's plus 1. Okay, so, yep, that makes sense. Okay, so we're going to sub in 2n squared plus 3n plus 1 into this first little bit. So it's n over 6 times 2n squared plus 3n plus 1. Okay, and then I'm just going to leave this plus 5n over 2 times n plus 1 for the moment. And then we add on 4n to that. And then it's just a case of expanding the brackets now, again. Okay, and you could have done this all on one step, but it might not have looked too good. Anyway, so just n over 6 times each of the terms in here. Sorry, one sec. Yep. Sorry, I just didn't know what I was doing there. Crazy. Okay, so anyway, it's just a case of expanding the terms in there. So, and this is n over 6, it's not a very good 6. So it's 2n squared over 6 plus 3n, sorry, it's 2n cubed over 6, what the hell? Plus 3n times n over 6, so it's plus 3n squared over 6. Or you could just say, well, we'll cancel that down in a minute actually. And then you do n over 6 times 1, so it's just plus n over 6. Okay, and then expanding the next bit, so it's 5n over 2 times n, which is obviously just 5n squared over 2, and then plus 5n over 2 times 1, so it's plus 5n over 2, and then you add your 4n. And what you would do then is kind of group together all of your similar terms, so you group together all the n cubed, n squared, kind of simple stuff, just simplifying it. Simple. Right, okay, so obviously we've only got one n cubed, one lot of a kind of an n cubed here, so it's simply just 2n cubed over 6, or you could say it's n cubed over 3. This is kind of almost looking like that, but anyway, we'll go over that in a minute. And then 3n squared over 6, well, you could cancel that down to plus n squared over 2. Okay, no, obviously not actually, don't do that. So, sorry, we've got 3n squared over 6, and then we've got 5n squared over 2. So essentially what we're doing there is adding a half to 2.5. So to make sure I'm not going. Okay, so that obviously gets you 3, obviously. So it's plus 3n squared. Okay, and then you group together the normal values of n. So you've got a sixth, 5 over 2 and 4. So it's a sixth plus 2.5 plus 4, okay, which obviously gets you plus 20 over 3, okay, 20n over 3. And what we've got to bear in mind is we want to equal to this n over 3 times n plus 4 times n plus 5. Now, what that essentially is there, as I said, you can always work backwards and see what, because this is the answer we've got so far, and this is totally right. There's nothing nothing acceptable. There's nothing that is illegal in terms of, well, obviously I'm not going to be arrested. I'll save that for some crazy times looking at the newspaper for that. But anyway, might be some psychopathic thing. But anyway, we'll get on with the glossy details of that later. You can always work backwards from this n cubed times n plus 4 times n plus 5. Now, quite clearly, what they've done there in this situation is they've got a quadratic, okay, and then, yeah, so what they've done is they've got the cubic, okay, taken n over 3 out of it, and then factorised it, okay, so in other words, you can always work backwards and say what's n plus 4 times n plus 5? Well, quite clearly that is n squared plus 9n plus 20. Okay, that's ideally the quadratic we need. And remember that is times by n over 3. So if you're not sure, okay, as I said, where you could work as far as you can from this show that thing, and you can always work backwards from the answer, okay, which is nice when it's a show that, but I wouldn't do it directly so the examiner could see it. Might cross it out later on, just say it's a bit working and get away with it, so always cheating. Okay, so anyway, there's nothing wrong with that, by the way. So you only times this all by n over 3, and if you were to do that, obviously you would get n cubed over 3, and then you would times 9n over n over 3, okay, which is obviously just going to get you 9n squared over 3, which just cancels down to 3n squared, and then you times it, and then you plus 20n over 3. Oh, look at that. That's exactly what we've got here. We've got n cubed over 3 plus 3n squared plus 20n over 3. And what we need to do here is quite clearly, because as I said, what they did there was they had a cubic, and this is n cubed over 3 plus 9n squared over 3, which obviously cancels down to 3n squared, okay, plus 20n over 3. And what they've done is taken n over 3 out of that as a common factor, okay. So clearly the next step we need to do here, from working backwards, is take out n over 3 as a common factor. Okay, so if we take out n over 3 of that quadratic there, sorry, quadratic, what the hell are we doing? Cubic, sorry, obviously we get, well, n over 3, take out, n cubed over 3, and you take out the common factor of n over 3, it obviously gets you n squared. Okay, and then what we've got here, this is kind of the confusing bit almost, is we've got 3n squared. If we take out the third, well, if you divide 3n squared by the third, you get 9n squared. Okay, so we plus, sorry, not 9n squared, we plus 9n. And then we take, take n over 3 out 20n over 3, we get just plus 20n. Okay, so the next step we need to do when we've got that quadratic divided by n over 3 is now factorise this quadratic. And quite clearly, because we've worked backwards here, it's very easy to do this. So it's n over 3, and the factors are n plus 4 times n plus 5. Okay, and that is your answer. Okay, so you see how working backwards here actually enabled us to find out what the end answer should be. Okay, so that's a bit of a heads up. Right, so if you do want to copy that down, I'll just get out of the way. But I'm just going to check the focus to make sure you can copy it down. Okay, so, I mean, that's believable, so I'll just give you a few seconds to copy it down, and then we'll move on to the next question. Okay, so this is the next little bit, part B. We're asked to show that the sum of r plus 1 times r plus 4, so kind of the same one we had up here. However, this time it's between 2n and r equals n plus 1. Okay, now we've done the sum of r plus 1 times r plus 4 before, but the limits then were n and r is equal to 1. Okay, so how the hell are we going to work this out? Now, we can't do what we did before, work backwards, okay, because we're given it in terms of these other two values, a and b, okay, so obviously we can't work backwards because we need to know what a and b are, if we could do that, but obviously, so therefore we can't. And I think the best way to explain this is probably, well, we definitely know, whatever n is, it's an integer, okay, it's going to be a number, alright? And if we relate that to basic series knowledge, okay, because that's all this is just simply series, okay, so if we had something like, I'll give you an example here, very, very swift example, okay, so if we were asked to find the sum between 5 and 3, okay, say of r squared, what would you do? Say if it said, find the sum of r squared between 5 and 3, what would you do? Well, what you would do is you would go, well this therefore is equal to the sum of 5, between 5 and 1 for r squared, minus the sum of r squared, but between 2 and 1. Okay, so I do apologise about the noise, but there's humans in my house. They're there. Okay, so anyway, what this essentially is saying, okay, is this is right. Okay, so we're asked in between the sum of r squared between 5 and 3. Now that's not the answer to part B, by the way. This is just kind of to help you to answer this question. Okay, when it's got the numbers between 5 and 3, because if you think n, okay, as 2, okay, and r is equal to 1. Yeah, just assume this was the values for n and the first part A, okay? So this was your answer for part A, okay? Just imagine that for a second. And what this says, I know it's not exactly, specifically like this, but now it's asking for it between 5 and 3. But we know what it is between 2 and 1, okay? 5 and 1. But we can't work it out just by doing some equation and putting in 5 and 3. So we need to work out, basically, this number here, 2, is... So this number 3, okay, is 2 plus 1. That's very basic. But what it's saying here is this is... Say we said this was n, okay? So what this is essentially... I know it's 2 plus 1, but we said 2 was n. It's essentially n plus 1, okay? Which is exactly what that number is there. Okay, so hopefully that makes sense. And this 2n, it just means the next one up. But we'll get into that in a minute, okay? So, hopefully that makes a bit of sense. So, this is the principle that you need to understand. This bit here will be taken away. Basically, what we're doing here is we're subbing this new value. Now, I put the new value of 5, but we really know it's 2n, okay? And because it's not asking for r between that and r equals 1, it's r equals n plus 1, if we work it out for what n is, okay, we have to take away from that what the sum of between n and 1, okay? We know what the sum between n and 1 is equal to. Well, we've just worked it out in part A, okay? And generally, you should have already... Another hint is that part A generally leads to part B, and that kind of highlighted by the fact it's the same sum, okay? So they wouldn't have just... That would have been too much of a mistake. Sorry, not mistake. Coincidence for them to make without having some mathematical relevance to the question, okay? As opposed to physics relevance to the question, obviously. Okay, so hopefully that's a good enough explanation for you. Essentially, what we're going to do is sub in our new value, okay? So, as I said, the 2n was... I just said that was 5, even though it's quite clearly not, okay? If we said n was 2. Right, yeah, so hopefully that makes sense. If it doesn't, hopefully the calculation will do. Now, okay, so... Right, that's pretty basic. Right. Okay, so basically what we're going to do is sub in our new value of 2n, and it's going to follow a similar principle to that, okay? And then we're going to take away from that this value we've worked out in part A, because that's essentially n, it's 1 less than n plus 1, okay? Obviously. Okay, so... what we really need to do, because this is 2n, and what we subbed in before was n, so wherever we would see n in this previous equation, we're now going to sub 2n. Okay, so this is equal to, basically this equation, what we're doing is subbing in 2n and taking that away from when we sub in 2n to that answer. Okay, so the original answer was n over 3 times n plus 4 times n plus 5. So that's going to be the answer to this sum, okay? And it's the same sum, so it's going to be the same answer, but obviously the limits are going to be different, so we'll sub in different limits for n, okay? So this highest limit here is 2n, so we're going to sub 2n to be n in each one of these. So it's 2n for n over 3, okay? So it's 2n for n, so it's going to be 2n over 3. 2n for n, I mean n plus 4, so it's times 2n plus 4, and so on, times 2n plus 5. But because all that is, if we just left that as the answer, it would be equal to the sum of between 2n and r equals 1. But we don't want that. We want it between the sum of r of n plus 1. So we have to take away this answer we've got in part A. Okay, so we take away from that n over 3 times n plus 4 times n plus 5. Okay? So now it's just a case, well, what we can do to make it, because we know we've got to have n over 3, so basically this answer is going to be some kind of quadratic, again, similar thing, but we can't work backwards this time. We know it's going to be some kind of quadratic with a n over 3 as a common factor. And if we look at what we've got already, well, the first one is 2n over 3 times all of that, and the second one is n over 3 times all of that. Okay, so we can take n over 3 out as a common factor for both. Okay, so that's what we're going to do next. Okay, so if we take out n over 3 as a common factor, I'll just put it in big square brackets. Okay, so if we take n over 3 out as a common factor, the first one, we're just left with 2. Okay, because we've taken out n over 3 as a common factor. Okay, so we're left with 2 there, and then we still times it by 2n plus 4 times 2n plus 5. Okay, and we're taking away from that, well, we've taken n over 3 as a common factor from n over 3, so it's just going to be 1, or no, right 1. So it's minus n plus 4 times n plus 5. Now you put that back in square brackets there. Okay, so your new line, well, what we need to do now is expand all of these terms. Well, hopefully you should know that n plus 4 times n plus 5, well, kind of works it out before, kind of we did, okay, which was n squared plus 9n plus 20. Okay, so that's what n plus 4 times n plus 5 is. Well, there's 2n plus 4 times 2n plus 5, okay, which is obviously going to be 4n squared, 2n times 2n, plus 4 times 2n, 8n, plus your 2n times 5, 10n. So it's 8n plus 10n, so it's 4n squared plus 18n, okay, plus 4 times 5, which is 20. So the expansion of 2n plus 4 times 2n plus 5 is 4n squared plus 18n plus 20. And the expansion of n plus 4 times n plus 5 is n squared plus 9n plus 20. And the reason is we're going to take these two away. However, this 2n plus 4, okay, times 2n plus 5, we've already times that by 2, okay. So what we need to do now is times this 4n squared plus 18n, plus 18n plus 20, because that's the expansion of 2n plus 4 times 2n plus 5, and that's times by 2 over here, so we're going to need to times all of it by 2. Okay, so that obviously becomes 8n squared, and then obviously 18 times 2 is 36n, okay, and then you add plus 40. Okay, so what we're doing here, we're just going to sub in our values now. Okay, so n over 3 is still out as a common factor. Okay, we said 2 times 2n plus 4 times 2n plus 5 was this 8n squared plus 36n plus 40, and we're taking away from that, okay, this, now we need to put them in brackets, okay, because not necessarily for the first one, but definitely for the minus 4 n plus 4 times n plus 5, otherwise you might miss some double negatives. Now that's not going to happen in this particular case, okay, because it's all positive, but you just need to be aware of that, okay. So it's a common mistake to make that. If one of these was, say, n minus 5, you could, well, we're taking away, obviously we'd end up taking away a negative, so we'd end up adding it on. Okay, now we'll say that doesn't necessarily apply in this question, but just need to be aware that you put them in brackets, because n plus 4 times n plus 5, well, that's in brackets, okay? So you need to, when you expand it, you need to keep it in the same bracket, so you can work out exactly what we're taking away and what we're adding on, if there's any negatives, okay? I mean, if there's any double negatives, because we're taking away negative, if if it was n minus 5, for example. Okay, so kind of a crap explanation, but you get the idea. And we said n plus 4 times n plus 5 was this n squared plus 9n plus 20. Okay? So, it's just now a case of expanding this, simplifying this. So, well, we've only got n squared there, so it's 8n squared minus n squared, so it's obviously 7n squared. Okay, and then we've got 36n minus 9n, which is plus 27n. That's right, isn't it? Oh, is it? Sorry, that's probably wrong. I know it's a long day, but just need to double check. Can't believe I didn't believe myself there. 27n, yes. And then it's 40 minus 20, which is obviously just plus 20. Okay, so we've got the 7n, so basically we need to have it as n over 3 times n plus 1 times an plus b, okay? And I'm no expert, okay, but I'm going to find it quite difficult to factorise this 7n squared plus 27n plus 20. Now it kind of helps that we've got n plus 1 as a factor, okay? So maybe it does, maybe it doesn't. And maybe you could just do it off your straight head. Okay, so we've got it in the form, we just need to factorise this 7n squared plus 27n plus 20 business, okay? But obviously one of the factors is going to need to be n plus 1, okay? And then that obviously means the other factor is going to be 7n plus 20. Okay, and that is your answer. And you might mistake A is 7 and B is 20. Okay, so hopefully you can see how we've got to that. It's kind of, as I said, it's good if you relate these to actual numbers, and I tried to give a bit of a comparison there. But quite a hard question, I think, to be honest. It's just kind of, I mean, you just have to think it's only series, so what do we currently know in series that could apply to this question? Okay, and apart from subbing in formulas, you just need to be aware of, you know, when you're working out the sum between 5 and 3, you need to do the sum of 5 and 1 minus the sum of 2 and 1, okay? Now you can't do the sum of sum of r squared between 5 and 3 minus the sum of r squared between 3 and 1, otherwise you'd be taking away the sum of 3 twice, and that wouldn't make sense, okay? So, hopefully that makes a little bit of sense. Right, but again, if you want a bit more clarification on that series stuff, then obviously there is do a video on that, so please do check that out if you're not 100% with series. But well done for making it through the video. It's not been the best or the most entertaining one. It's not been jumping around and making a mockery of people at the moment, so should all be good. Thanks for watching, and we'll see you next video.